So, I think till now we have seen like the basics to step into this particular operating system and all, like what we have to do and all. So, in order to proceed further, there is another topic which we have to know a bit. That is nothing but networking part. So, networking part in the sense, once let's say you are working as a cloud administrator, or let's say a normal administrator like Linux operating system administrator, or let's say you are trying to form Kubernetes cluster or something, whoever it is, you have to understand a bit about a networking part. Why is that needed? Because even for troubleshooting part as well. So when you're working further in coming tools like Kubernetes or Docker or any other tool, we have to know a bit about networking. What is CIDR? What is IP address? What is netmask? Okay, what is subnet? And then what is your gateway broadcast? So what is a route IP? So these things we have to know so that you will be comfortable in handling on your own. See, it's not the job of a network engineer where he will come and configure the networking part in your operating system, right? So you have to be in a position to configure that. His job is only to see whether all the switches and all the routers are working properly in the data center, and then a proper IP address was allocated to you. So this is the job of a network engineer. Once a network was allocated to you, you have to be in a position to assign the IP address to your systems or the nodes or the cloud, whatever it is. You have to be in a position to be configuring for that. Okay, so for that reason only we are trying to understand this networking part. So what is the first thing that we have to understand in the networking? So as you all know that internet service providers, so internet service providers are someone who will provide your internet connectivity for us, right? So let's say we have so many devices like printers, monitors, CPUs, sorry, we have computers, laptops, mobiles. Okay, we have printers. There are so many devices. These devices needs to communicate with each other, right? They have to communicate with each other. So as a user, I can call someone with their name and I can talk to him, right? Let's say my name is Sudhir, right? If I want to call someone like Harsha or someone, Aditya or someone, I can call with their name because they were they were, what do we say, they were identified with their names, whatever it is, a common name or surname, whatever it is. They are identified with their name itself. So similarly for the devices in the networking world, in this particular IT world, every device will have some IP address. Okay, will be allocated, whether it is a private IP or public IP, it's a next level, but a IP address will be assigned to reach to that particular device. Okay, so which means that let's say a printer wants to communicate to the computer to print something and all, it needs some IP address, right? So the IP address is a point of reference to transfer the packets from one device to another device. A device can be anything. It's up to your imagination. It can be a mobile laptop or a PC or a printer, okay, or any other devices. Okay, now this is how the diagram looks, a simple diagram. So let's say at your home, everybody's architecture is the same. Right now, internet service provider, it can be Act Fiber or your Airtel or Geo or whatever it is, you will be contacting them. You will be subscribing for their particular networking, and they will give you some public IP address. Okay, and if you see that public IP address also not constant, it is a DHCP actually. Okay, in their side they will enable the DHCP, so that automatically whenever you restart your router or restart your device, automatically you will get a new public IP address. Okay, but the concept is simple. You will get a public IP address from the internet service provider. Okay, now with one IP address, how many devices I can attach? Only one device, right? IP address, IP in the sense internet protocol. That internet protocol address can be allocated to only one system, one device actually. It can be either laptop, or it can be a PC, it can be a printer, it can be a PlayStation, whatever it is. Smartphone we cannot, right? It doesn't have a LAN cable. Okay, so the LAN cable can be attached only to the desktops, laptops, printers, and PlayStations or something like that. but for smartphones and all, you cannot attach that, right? So now this public IP address, I have these many devices at my home, but how I can get an internet connection? So the simple thing is, we'll be using a concept called router. With a single IP address, I can attach multiple devices to this particular router. So what router will have? Router will have a private IP address. Router will have a private IP address network. In that network, when you attach a device to your router, automatically you will get an IP address actually. If you watch closely, when you open Wi-Fi in your mobile, right? When you try to open that and attach it, automatically it will contact to your that particular device, a router, and then it will allocate some IP address to your device. Okay, this is what happens in the background. So that's how you get an IP address to your any device, whichever you try to connect to your router. The IP address which you see in your mobile or in your PC or in your laptop, which is connected to the router, will get a private IP address. Private IP address in the sense the IP address which will be reachable only within the LAN. LAN in the sense local area network. Local area network in the sense within the router, it can communicate with each other. But from outside, if I want to communicate to this particular laptop, 192.168.0.101, I cannot reach to that. Why? Because it is a private IP address, so it doesn't know how to reach to that particular destination. And if it is a public IP, yes, I can reach to it. But I have only one public IP address that is attached to my router, and router is giving me the private IP address, so it is not reachable. Okay, so if you give this public IP address, it can reach to till router, but after reaching the router, it doesn't know to whom it should contact. Okay, so that is one more thing which you have to understand. So with this, now we have solved the problem like with one public IP address which we are getting from the internet service provider, we are able to get these many devices connected to my single public IP address. If I want all the devices to be connected in a public, then I need to contact to the internet service provider. I need to ask more IP addresses to him. So I need to pay for that. Every public IP address is we have to pay for that because they are also purchasing from someone else. Internet service providers are not the actual people who will be getting the public IP address. They need to purchase from someone else. That someone else, I will tell you who are they. Okay, so they are the decision makers actually, worldwide. Okay, so they from them they will get the IP address, and that's how they will give you the one public IP address to your home. Okay, home network. This is the general scenario how it works. Okay, if it is a switch, right? You cannot do that because if you have multiple public IP address, and let's say they were given you 6 IP address, public IP address. Now what you can do, you can attach that LAN cable to the switch, and from the switch with the LAN cables you can attach to your PC, laptops and all. So that's how you can allocate the IP address. But mobiles and all you cannot connect, right? It needs a Wi-Fi. Wi-Fi is possible only in the router itself. Okay, so these are the things which you have to consider, like basic things, how the networking works in the real time world. So as we discussed, we are talking about IPv4. We are not talking about IPv6 address. IPv4 in the sense Internet Protocol version 4. So version 4 in the sense it will have what is the size of this IP address is 4 bytes. 4 bytes in the sense each each byte is equal to 8 bits. Okay, 1 byte is equal to 8 bits. So totally 4 bytes. Each byte is represented with a dot symbol, separated with a dot, right? So first byte dot, second byte dot, third byte dot, fourth byte. In each byte you will see 8 bits. 8 bits in the sense ones and zeros. So the total size of this particular IPv4 is 4 into 8, right? See, we have 4 bytes. In each byte we have 8 bits. So totally what is the size of your IPv4 address? It is 32 bit size. Okay, so the size of the IPv4 address is 32 bit. Okay, you have to remember this. Okay, it is so simple. IPv4 4 into 8 32. Okay, now if someone asks you like what is the size of the IPv4 address, it is 32 bit. Why 32 bit? 4 bytes into 8 bits. Okay, so it is totally 32 bit. Now, okay, that's fine. 32 bit size. Okay, fine. Okay, now how it is represented? Okay, so it is represented in the form of ones and zeros combination. Okay, it is represented in the form of binary ones and zeros. Okay, the starting IP address of your IPv4 is let me write like this: 1 2 3 4 5 6 7 8. First byte was completed, right? Second byte: 1 2 3 4 5 6 7 8, 8 bits. Dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. Okay, so this is the representation of minimal IP address, minimum IP4 address. It is minimum IPv4 address. It is, so it is represented in binary format. Binary format. Okay, now okay, fine. Now if you try to convert into decimal format, to convert into decimal format, does anyone know how to convert into decimal format? In like in our graduation, we used to get these things, right? Converting binary into decimal, decimal into octal, octal into hexa. So these are the flows, right? So how will you convert your binary into decimal? Any guess? To convert, we use 2 to the power of, okay, the index value, right? 2 to the power of index. Okay, index, or we call it as position. Okay, generally we call it as. Now you start counting your position from the left hand side. Okay, each byte is individual, so you have to count your position like from the left hand side to the right hand side. So totally how many bits we have? 1 2 3 4 5 6 7 8. Okay, that's fine. Let me divide this actually with spaces, so that we'll get some proper spaces actually, so that I can represent this properly. Now these are the 8 bits in the first octet, or let's say in the first decimal, in the first byte. Okay, now on the from the left hand side you need to count, right? So 2 to the power of, actually if you start to be simplified, you can count from the right hand side. Okay, first one is nothing, this one is nothing, but totally how many bits we have? 8 bits, right? So 8 bits in the sense, actually this will look like 2 to the power of, yeah, 2 to the power of 7. Okay, next one is nothing but 2 to the power of 6. Next one is 2 to the power of 5. Next one is nothing but 2 to the power of 4. Next one is nothing but 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, and 2 to the power of 0. Okay, this is how it is represented. Now what is the 2 to the power of 7 value? No guess. What is the 2 to the power of 7 value? No. Okay, so 2 to the power of 7 is nothing but 128, right? So the value of 2 to the power of 7 is 128. Okay, and then what is the 2 to the power of 6? 64. And 2 to the power of 5, 32. Okay, and then 16, and then 8, 4, 2, 1. To the power of 0 is 1, right? That's how it is. To the power of 1 is 2. Okay, or to the power of 2 in the sense 2 into 2, 4. To the power of 3 in the sense 3 times 2 into 2 into 2. So it is like 8. So this is how it represented. Now if you try to do the sum of this particular value, okay, if you try to do the sum of this 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, okay, it is represented as, see, all the positions are occupied in the sense all are represented as 1 1. Okay, this is the maximum, what do you say, maximum IP address in IPv4. This one, you can say like 1 1 and then 1. Okay, all are occupied. So now if you do the sum of this particular value, What is that? 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So it is nothing but 250. I write 255 or 256. Okay, let me know. So this is how it is. So the minimum IP address for all zeros is 0. That is the decimal format. Okay. The minimum IP address for all zeros is 0. Okay. For all ones, the value is 255. Okay, that's how it is represented. So the minimum IP address in IPv4 is 0 and the maximum is 255. Now if you write in all the sections 0.0.0.0, this is the decimal format. Okay, and the maximum value is 255.255.255.255. This is the maximum IP address of IPv4. Have you ever seen IPv4 greater than this? No, you will never see actually. Okay, that is not possible actually. As per the standards, we have to follow. Okay, so as per the representation, also this is the maximum value in each and every byte. Okay, so till here, have you understood like what are the concept I have told, or still confused? So the minimum IP address in IPv4 is 0.0.0.0. Okay, and the maximum IP address of IPv4 is 255.255.255. If someone asks you why 255, because it is represent, if all are ones, it should be represented with 2 to the power of index value, position value, 2 to the power of 7 plus, 2 to the power of 6 plus, 2 to the power of 5 plus, 2 to the power of 3 plus, 2 to the power of 2 plus, 2 to the power of 1 plus, 2 to the power of 0. The sum of these particular values is equal to 255. Okay, so the maximum IP address in IPv4 is 255. Okay, so this is how it will be represented. Okay, I can make it here actually. All are ones, right? So then it is called as 2 to the power of 1. Okay, so this is how it is. Now the same thing I have written in the table. If you scroll down a bit, this is what I have written. Okay, so first byte, the minimum is 0.0.00080 zeros, and the maximum is all are ones. Okay, here you can see minimum IP address is 0.0.0.0, maximum IP address is 255.255.255. So that is what I have written here. Okay, if you want, you can just see this particular table and how it is converted, how it is represented as zeros and 255. Here you can see here, if it is 1, it is occupied either, I see the binary value will be on this position either 0 or 1, 0 and 1's combinations, right? What I'm telling is, if all are zeros, that is a minimum. If all values are ones, all the positions are 1, that is the maximum value. Okay, the maximum IP address. Okay, in between there can be so many combinations, right? Zeros and ones combinations. Okay, 00001, 00010, 0011, 0000100. So these are the combinations actually. Okay, so this is how it is. Okay, this is how the table was written. Now this minimum and the maximum IP address, in between we have so many IP addresses, right? In order to maintain this and to allocate this particular IP address, they have divided into classes. Okay, they have divided this particular large IP address into small chunks. Small chunks in the sense they were divided into small numbers so that it is easy to identify and represent. Okay, so that's the reason they are called as at classes. How many classes we have totally in IPv4? Totally we have 5 classes. Among them, the general purpose classes are, which we can use as nothing but class A, B and C. Class D and E is not allocated to the general people. You can see you will not get any IP address from this particular range. Okay, this is only for R&D and research. It is not for us. Okay, so that's the reason you cannot see it for your websites, google.com or anything. You don't see it for. Okay, you will see only this for your research and development like ISRO, NASA, like those people will be using this kind of IP addresses. Okay, and who will decide this, or who made this particular decisions, like this is IP address, this is the minimum, this is the maximum, these many classes we have. Everything was designed by your IANA. Okay, Internet Assigned Numbers Authority. So these are the global people who will be allocating the IP addresses for the internet service providers or to you. Okay, So they are the decision makers, okay, who will be representing this IP address globally managed. Okay, because they have to maintain the records, right? Which IP address was already allocated, so that you cannot give the same IP address to all other people in the globally. So it can create a mess, right? See, the same IP address cannot be used by multiple devices. That is not possible. Websites or device, whatever it is. Okay. So that's the reason these are the people who will be maintaining the record of this public IP addresses and all. Okay. So if you see the class A, B, and C, the IP address which starts and ends in class A is nothing but out of this 0.2 to 55. So it will start from 0 or 1 and it will end at 127. You can represent or you can identify your class by looking at the first byte. By looking at the first byte of IPv4 address, we can tell like whether it is a class A, B, C, D, or E. Okay, how you can see this? So let's say it is starting either, some people will say like it's 0.0.1, from it will start from there, and then your maximum IP address in class A is nothing but 127.255.255.255. That is a maximum IP address in class A. Anything apart from after that is called as class B. Okay, you can see here class B is starting from, if you add 1 here, it's 0, it's 0, 0, and it is 128, right? So that's how you can see here. So 128.0.0.0, it will start from there and it will end at 191. 191.255.255.255. That is a maximum IP address in class B network. In class C, we can see here 192 is the next IP address and 192.0.0.0, and it will end at 223.255.255.255. This is class C network. Okay, this is how it is. Class D and E is not needed for us, but still let us try to understand. Class D starts from 224.0.0.0 and it will end at 239.255.255.255. Okay, and the class E starts from 240.0.0.0 and it will end at 255.255.255.255. This is the maximum IP address. Okay, so among these IP addresses what we have in each and every classes, few IP addresses we don't allocate to your devices globally. Globally or internally, whatever it is, you don't allocate this IP address at all. Those are nothing but 0.0.0.0, 255.255.255.255. You don't see any website or a device which is allocated with this IP address. You can search in Google. Can you see any website with 20.0.0 and 255.255.255.255? No, it is not possible. Okay. And one more IP address which we should not allocate to reach to the device is nothing but 127. 127 IP address is a loopback IP address. Okay. Loopback IP address in the sense every operating system will create a default interface called LO. Okay. Loopback interface, which will be allocated with 127.0.0.1 IP. Okay, from this network series actually. Okay, any IP address which is starting with 127.0.0.1, 0.0 to 127.255.255.255. This IP address which falls in this is called as loopback IP address. This IP address is works only internal purpose, means within the system or within the device. From outside the device, if you try to reach to it, it is not possible. Okay. For example, it looks like this. For example, let's say I created a VM. Whether the VM is created in cloud or in your local system, it's up to you. So what I've done after the VM is created, I installed Ubuntu operating system or any other operating system. Okay. And this Ubuntu, okay, was attached. Let's say my VM was attached to NAT. For example, in my VM, this is NAT network. Okay. This is NAT interface. Okay, my system was connected, my device was connected to that. Means my VM was connected to that cable. Cable in the sense it can be a software connection or a physical connection. Now this particular operating system is having two interfaces. One is by default it will have LO interface, okay, which is having 127.0.0.1/24. or something like that. Okay, you'll get this by default. Okay, and there will be one more interface called enp0s3, for example, that you'll get an IP address from the NAT 10.0.2.15. That is what we have seen. Okay, that is what we have seen. Now, if I try to do ping, okay, 127.0.0.1, it will work within the system because it is within the system. Okay, now from outside, if I try to do a ping, let's say from my base machine, okay, let's say this is my base machine, right? On top of that, I created a virtual machine. Now, from the base machine, from the base machine, let's just a second, let me wipe out this. Yeah, so from the base machine, if I try to run ping 127.0.0.1, it works, but from where it is getting a response, because your Windows laptop also will have this IP address. If you scroll up, let me show you the proof. I think here it is not represented, but you will see here. Okay, I think here it is not shown. Let's scroll up a bit. Okay, so anyway, so this IP address will be there. If I try to run ping, let's say I don't have any system right now. Let me open this and let me run ping 127.0.0.1. It works. See, to which system it is? You're getting a response. See, I sent 4 packets. I received 4 packets. There is no lost packets. So it is successful. 100% ping has been worked. But from which system you got a response? Did I got a response from my own system or from the Ubuntu operating system? So it is from your own system, because every operating system will create a default interface called loopback interface. That is nothing but 127.0.0.1 IP address. Okay, one or anything, any IP address with the details which I have shown here. Okay, and there is one more IP address which is called as 169.254.0.0 to 169.254.0.16. These 16 IP addresses are called as link local addresses. This you should not attach to your system. This IP address will get only when your DHCP was failed, right? See, I sent a DHCP request and my DHCP server was not responding. So automatically it will assign an IP address called this link local addresses. Okay. So don't worry about this link local addresses right now. So apart from this IP address, you can attach any IP address. You can assign any IP addresses to your devices. Okay. This is a point which I want to make. So any questions in this? Any questions, please? Let me know if you're not able to understand, if it is, uh, if you're not able to catch my speed or something like that, please let me know. Okay. You can just open up. No questions? Fine. Okay. So now this is how it is. Now let's say, okay, this is fine. I understood. Okay, what is class now? What is class B, C, D, and all, and E as well. Now, how I'll make a decision? How many systems, how many devices can be connected in a network? So, network in the sense, technically we call it as network, right? Network is a number of devices that will be connected with each other to communicate. Okay, in order to communicate with each other, the devices will be connected in a network. Okay, so the network will be represented like this, you can see here. Okay, and then with the network you cannot understand how many devices can be connected. Okay, the CIDR value will tell you how many devices can be connected in this particular network. Okay, so this is your network. Okay, and this is your subnet. The combination of network and subnet is nothing but, it will tell, it is called as CIDR, classless inter-domain resource. Okay, CIDR. The combination of network and the subnet is called as classless inter-domain resource. Okay, CIDR. Okay. Now, Okay, you understood this particular point, but how it makes a sense to me to calculate the IP address? For before that, you have to understand what is subnet. Subnet, the default subnet for class A, B, and C is nothing but D and E doesn't have any subnet. Whatever the IP address was given, you can directly allocate to your system. Okay, but for class A, B, and C, it is not like that. Okay, for class A and B and C, the default subnet is class /8, and for B it is /16, and for class C it is /24. Okay, what does it mean is nothing but it is also represented in IPv4 format. Your subnet mask is also represented in IPv4 format. It looks like this. /8 in the sense what? Only 8 bits are occupied out of 32. See, 32 is your maximum number of bits in an IPv4. So I'm saying here class A, the default subnet is /8. /8 in the sense only 8 bits are occupied. 8 bits are occupied in the sense only first byte will have all ones. All the other bits will be zeros, right? So if all are ones in the sense what? The maximum value is 255. So next values are zeros in the sense what? 255.0.0.0. That is how it is represented in decimal format. Okay, that's how it is decimal represented in decimal format. Okay, so one 8 ones dot 8 zeros dot 8 zeros and dot 8 zeros. Okay, so the decimal format is 255. Sorry, binary form. Sorry, decimal format is 255.0.0.0.0. Okay, that is how it is represented. What does it mean? 8 bits in the sense 8 bits are network bits, rest of the bits are host bits, which means that 8 bits are network bits, which means that they will never change. Okay, that will be common for all the devices which are attached in this particular network. Okay, if I give you a network, okay, if I say /8, okay, 8 bits will never change, which means that all the devices, this 8 bits are common. Rest of the bits we have 24 bits, right? These 24 bits will change from device to device. Okay, so that's how it is represented. So that's the reason the bits that never change is called as network bits. The bits which will change is called as host bits. So the host bits will tell you how many devices can be connected in a network. Okay, so that will tell you how many devices can be connected in a network. Okay, so the default value is 8 in class A. In class B it is nothing but 16. In class C it is nothing but 24. Okay, I'll tell you how we need to calculate, how it makes a sense to me, like these many devices are can be connected and how it is represented and all. But right now just make a hard code representation saying that the default value for class A is /8, for B it is class /16, and for class C it is /24. Okay, so /16 in the sense what? Totally 16 bits are ones and rest of the 16 bits are zeros, right? So which means that 255.255.0.0. Okay, for /24, which means that 24 bits are occupied, rest of the 8 bits are zeros, which means that 255.255.255.0. That's how it is represented in decimal format. Okay, so this is how 24 bits are network bits and 8 bits are host bits. This will keep on change from device to device, host bits. Okay, is this point is clear? Because if you understand this, then only we can go forward. Okay, any questions, please stop me here. So please let me know. If not, we can go forward. Okay, yeah, so this is how it looks. So the first byte will is network ID, and the second byte, third byte, and fourth byte in class A is nothing but host ID. And for the class B, first and the second bytes are, because it is /16, right? So the first byte and second byte is nothing but network ID, and the third and fourth are nothing but host ID. Okay, so the first in the class C it is /24, the default subnet mask. So that's the reason the class C will have the first byte, second byte, and third byte to count 24. First byte will be occupied, second byte will be occupied, and third byte also will be occupied. Then only it is called as /24, and rest of the 8 bits are host bits. So that's how it is represented in green color, you can see here. And class B, D, and E are like multi-class added and reserved, so we don't bother about this right now. because we don't come across this particular things in productions or wherever you do. Okay, now let us take a simple example. Okay, now let us take a simple example and let's see how to calculate the number of devices that can be attached in that particular network. Okay, so simple example is nothing but, let me take this example which I already used to. Okay, so let me show till here, or let me take this. Let me take this one. Okay, let me open a notepad, another notepad. Okay, so now this one. So this is your IP address. This is the IP address which was given by your network engineer. He has given to you. Okay. Now you have to make a decision like how many devices can be connected. Anyway, first of all, we will tell them how many devices we are trying to connect in this particular network. Based on that, they will calculate and they will give you a CIDR. Okay. After that, you need to allocate the IP address to your systems. Let's say this discussion was already happened. So based on that, they have given you a class C network. Okay, let's forget this private IP actually, but still let us try to understand. So 192.168.120.0/24, this is the CIDR which was given to you. Now what is your network? Now your network is 192.168.120.0. What is your subnet? Your subnet is 24/24. So how will you represent that? So 255 dot, all bits are ones. So 1, 2, 3, sorry, 1, 2, 3, 4, 5, 6, 7, 8 dot. So 8 bits are covered. 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 8, 16 bits are covered. 1, 2, 3, 4, 5, 6, 7, 8. 24 bits are covered. Dot 1, 2, 3, 4, 5, 6, 7, 8. So rest of the bits are zeros, right? So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now if you convert this into decimal format, it will be 255.255.255.0. And now this is your subnet mask. So your subnet mask is 255.255.255.0. Okay, the combination of this is nothing but CIDR which I already told. So which class it is? Which class is your CIDR? So can someone tell me which class it is right now?
C.
Yeah, class C network, right? So by looking at the first octet, sorry, first byte itself, you can understand. So 192 in the sense it falls in class C network, right? Sorry. So if you look at this, it falls under class C network. You can see 192. Okay, that's fine. Okay, now it is class C network. What is the default subnet mask for class C network?
24.
Class C. Sorry, 24, right? For that also it is 24. Okay, so these 2 points are important for us. So your class is class C network, your network is from class C, and what is the default subnet mask for class C? /24. Okay, and your subnet mask is also 24. Okay, so remember these 2 points. Okay, now how I can tell how to calculate how to calculate how to calculate number of, okay, what do we say, like number of network bits or host bit, which we, this is a formula, okay, which we have. Okay, how to calculate the number of device or the networks. Okay, number of networks we can create in this particular CIDR. Okay, so for that, to calculate, a simple formula is 2 to the power of n. What is n here? N is nothing but number of bits, okay, borrowed from, okay, from host ID. So the number of bits which are borrowed from host ID, from host. Okay, now what will be the answer for this? 2 to the power of n. N in the sense, did you borrowed anything additional? See, your subnet mask is /24. Okay, and what is your subnet? It is /24. Did you borrowed anything? No, right? So it is 0. So 2 to the power of 0, what is the value? 1, right?
One.
To the power of 0 is 1. So how many networks you have? One. Only one network. Okay. So in this CIDR, you can create only one network. In that network, how many IP addresses I can allocate, which means that how many devices can be connected. Let's say forget about devices. How many IP addresses I can utilize. So how to calculate that? So how to calculate number of devices, or let's say hosts in a network, number of hosts. Okay. Now this is what I have written here. How to find the number of IP addresses in each network. Okay. So that's how it is. So how to find number of IP addresses in each network. Each network. Now each network, in this is we have only one network. That's fine. So our job is almost simplified. So what is the formula? Here also it is 2 to the power of n. But n in the sense number of, okay, bits left after the borrowed. Okay, number of host bits. So number of host bits. So how many host bits we have here? Any guess? Okay, tell me which is network bit and which is host bit right now.
8-bit for host.
All these
8 bit.
ones, yeah, exactly. So all these ones are nothing but network bits, which means that this will never change. How many host bits we have totally now? After borrowed, see, we don't borrow, we haven't borrowed anything, so all the 8 bits are related to network bits. So now number of sorry, these are host bits. So how many host bits we have right now after borrow? Zero borrow, so obviously it is all the left portions are nothing but host bits. So how many we have? 2 to the power of,
8.
what is that, 8. So what is the value?
256.
Sorry, 256 or 8? Sorry, 255. 256, right?
2 power
So
8
these
is
are the
256.
maximum number of, sorry, yeah. So the number of devices or the number of IP addresses that can be used in a network, okay. So this is how it, which means that now I clearly know that, okay, I have only one network, and in that network I can attach these many IP addresses, I can utilize these many IP addresses. But there is a clause. All the IP addresses we cannot use. In that, the first bit and the first IP address and the last IP address we use for a purpose. Okay. So how many devices? How many devices can be connected in a network? In a network. Okay. So that is nothing but 2 to the power of n minus 2. Okay. The value is 2 to the power of n minus 2. Okay. So 2 to the n is nothing but number of host bits. Okay. Number of host bits. Okay. Now 2 to the power of n is nothing but, n in the number of host bits is nothing but 2 to the power of 8. So 2 to the power of 8 minus 2. What's the value? 254. Okay. So these are the number of devices that can be connected in a network. Number of devices that can be connected in a given network. Okay. So these points are clear.